Hello all. Previously we have seen structure of C program. Now in this particular video we will see data types in C language. Data type specifies the type and range of the data that a variable can hold. For example, if we declare a variable, which type of data that variable can hold, that can be decided by the data type. And also how much values, the range of values a variable can store. The maximum and minimum values also specified by the data type only. So these things decided by the term called data type. Let us see the classification of data types in C language. First one is primary or primitive. We can call primary as primitive or built-in. And the next one is derived data types. And next one is user defined data types. So in this particular video we will see only primitive data types in C language. What and all primitive or primary data types in C language? Integer, character, floating point, double floating point and void. We will see one by one. Let us try to understand what are primitive data types is. We can call primitive data types as primary data types or built-in data types or predefined data types. Let us see the definition first. Primitive data types are the basic data types provided by the language to represent simple values. So what do you mean by this? Primitive data types are already there in C language or built into C language to represent simple values or to represent as single values. In C we have different primitive data types as we already seen in previous slide. One is integer and another one is floating point, double floating point, character and then void. We will see one by one with examples. The first primitive data type is integer data type. Integer data type can be used to store integer numbers. That means positive values we can store, negative values we can store, zero we can store. We can store octal and hexadecimal values as well, but we will see with examples in upcoming slides. The operations performed on integer data types are addition, subtraction, multiplication and division, and bitwise operations can be allowed on integer data types. Don't worry about what are bitwise operators. We will see in the section called operators. Okay. Keyword int. There is some concept called keyword which we'll discuss in upcoming lectures. So we have to use int keyword to declare integer variables. These keywords are generally smaller case letters. So int should be written in smaller case. What and all memory size occupied by the integer data type is a compiler dependent. So what do you mean by compiler dependent? We have different compiler architectures or different OS architectures. Let us try to simplify this term. So what do you mean by compiler dependent? The memory occupied by the data type is compiler dependent. For example, in this slide I have mentioned memory size as 2 bytes in 16-bit compiler. So what do you mean by 16-bit compiler? So at a time CPU access 16-bit length of instructions and process the data. There are other type of compilers as well, like 32-bit compiler and 64-bit compiler. So CPU access at a time 32-bit instructions and then process the data, so that your accessing speed will be faster and calculation speed will be faster. So previously in the older generation we have 16-bit compilers and later 32-bit compilers comes into picture. Now 64-bit compilers also came into existence. So that is the difference between compiler dependent. We are using devcpp or turboc. Turboc generally follows 16-bit compiler. So in that we have 2 bytes for integer data type. Okay, so we can use size modifier as well, like short and log, so that we can decrease or increase the integer data type. And we can use sign modifier as well, or we can use signed or unsigned to represent positive or negative. So signed means we can represent positive or negative, unsigned means we can represent only positive. That is the meaning of signed and unsigned here. Let us try to understand the sizes of the integer data type. These sizes ranges of data type can be dependent on compiler. So whatever you are saying, these are with respect to the 16-bit compiler, or we are going to discuss the highlighted ones. So one is short signed int, another one is short unsigned int, third one is signed int, fourth one is unsigned int, fifth one is long signed int, and sixth one is long unsigned int. So let us try to recap from the previous slide. Signed means we can store both positive and negative. Unsigned means only positive. To short and long keyword, we can decrease the data type size with the help of short data type or short keyword, or with the help of long keyword we can increase the that particular data type. Okay, so these things you should keep in mind. Now we will see how signed int works, how this range of values can be proved. At line number here we have signed int, right? We have different kind of ranges here, minus 32,768 to plus 32,767. I will explain only signed int. You can deduce other data types as well. If you understand this, others are very easy. Okay, I will focus on signed int as of now. The range of values for this particular data type is minus 32,768 to plus 32,767. And one point you should remember, the sizes and ranges of int, short and long, or in general other data types as well, are compiler dependent. So whatever you are seeing, these are with respect to 16-bit compiler. That point you should remember. Now this particular signed int is a 2 bytes. 2 bytes means 16 bits, and 2 power 16 value is 65,536. We need to divide because signed can store both positive and negative, right? So we need to divide this range. So some half of the values goes for negative values, half of the values goes for positive values. That is what minus 32,768 to plus 32,767. 0 also included. So that is why one number is reduced from the positive range. And the format specifier of this particular data type is %d. What do you mean by format specifier? The format specifiers can be used in printf and scanf functions. This format specifier tells the compiler in which format we can take the input or in which format we can produce the output. That is what format specifier does in printf and scanf functions. For every data type, format specifier is there. For integer %d, for char %c, for float %f, for double %lf. These are the different format specifiers can be used for different data types. So these and all ranges and these and all bytes can be used for that particular data type. Now let us try to understand how unsigned int works. So as we already know, unsigned int can only store positive numbers. There might be some cases where we can only work on positive data only. For example, age cannot be negative, right? So where we have to work on only on unsigned int, that means positive numbers, in that particular scenarios we can only use unsigned int. So unsigned int means we can store only the positive numbers. So let us try to understand how this range comes in. So for example, int is 2 bytes, right? For 2 bytes means 16 bits. 2 power 16 value is 65,536, but we have to include from 0 as well, right? So 0 to 65,535. That is how that range comes for unsigned int with respect to the 16-bit compiler. And the format specifier for unsigned int is %u, %d for signed int, and %u means unsigned int. This point you should be very careful with respect to signed int and unsigned int. Now let us try to understand what float means. Float is a data type in C language. It is used to store floating point numbers and exponent data. What it means? We can store decimal point numbers, for example 5.3, 2.5. These kind of numbers we can store in floating point data type, and these numbers can be negative and these numbers can be positive, and 0 also can be stored in float. And what kind of operations can be performed on float? We can perform addition, subtraction, multiplication and division are allowed on float. And the keyword which we use it for float is float, and all keywords are smaller case letters. This point you should remember. We can use size qualifier on float like long, and the float is a single precision data type. That means typically provides 6 to 7 digits of precision. So after decimal point, how many points we can get the accurate value without roundup operation? That is called precision. So single precision means typically provides 6 to 7 digits of precision for floating point data type, and the format specifier for float data type is %f. The next data type is double. Double is a data type in C language. It is also used to store floating point numbers but with more decimal point values, because that range is doubled here when compared to float. Double can store a wide range of values when compared to float. Double is a double precision, meaning that it can represent more accurately with more decimal places, usually 15 to 16 decimal places after decimal point. As part of float is a single precision, as we already know from the previous slide. Float can store 6 to 7 decimal point precision after the decimal point. That means it can give accurately for 6 to 7 decimal places, while in double it can give 15 to 16 decimal places precision. That is why it is double precision. Float is a single precision data type and double is a double precision data type. Float can give the accurate digits for 6 to 7 places. Double can give 15 to 16 decimal places. The next data type in C language is character. Character is a data type which is used to store the single alphanumeric symbol. That means we can store alphabets and special symbols. So what do you mean by special symbols? We can store @ star or divided by. We can store these symbols as well as part of character data type. The keyword which we are using to denote character is char, char, that is in smaller letters. The memory size for character data type is 1 byte, that is 8 bits. I'm sorry for this mistake. It is 8 bits, not 8 bytes. I'm so sorry. I will correct it. The examples for character data type is char space C is equal to, we have to enclose that particular symbol in single quotes, because we can store alphabets, right? These alphabets we can store in single quote. So the values which we are storing in character, that should be enclosed in single quote, and the memory size is 1 byte, that is 8 bits, and the format specifier for character is %C. The next data type in C language is void. Void means nothing. It has a special meaning in C language that we can discuss later. But for now, please understand it can be used in function as a return type. That means if we use void with function, that function won't return a value. Void can be used with pointers. This we will discuss in pointers concept. This is a special type of data type in C language that we will discuss in pointers and functions. With that, we have completed primitive data types in C language.